Okay, we've got Orit Shaer tonight talking about tangible and embodied interactions for the future of work and learning. So we'll get on with the show and I'll pass it over to Orit.
Thank you, Joe. So it is always a pleasure to be with this forum. And I think that the last time I kind of met with this forum was just before COVID hit us. So it's nice that we found creative ways to be together. Let me share my screen. Okay, and I learned how to make sure that I can see the video panel. So it will take me a second to make sure that I can see you all as I speak. And I think we have it. So do you see my slides? Okay, great. So thank you, everyone. It's a pleasure to be here. I'm Orit Shaer. I'm a professor of computer science at Wellesley College. And I'd really like to start with this picture of my research lab at Wellesley. It's also a good picture to kind of wish everyone happy International Women's Day. As you know, Wellesley is a liberal art college for women. And the researchers in my lab are almost all undergraduate students or recent graduates of Wellesley. And the lab is a very it's a multidisciplinary environment. So we have students that come to the lab with backgrounds in computer science, in media art and science, psychology, biology, chemistry, education. And this multidisciplinary nature is really critical for the work that we do in the lab. So my research focus is on tangible and embodied interaction, which is an emerging form of human-computer interaction. And in this area, tangible and embodied interaction really focus on how our bodies, our movements, our physical environment can be used to access and manipulate digital information. And in this field, we strive to make the interface between humans and machine as transparent as possible. So in the last 5 years, actually, even more, I've been working very closely with Brig Ulmer, with Ali Mazalek, with Caroline Hamels on a new book that examine the cognitive foundation, conceptual foundation, technical aspects of tangible and embodied interaction. And in the book, we also set agenda for future practice and research in this area. So the book is in final production stages, and hopefully it will be available later towards the summer. It will be first available in the ACM Digital Library, and then it will be available in physical copies. And I'm really excited to share with you some highlight from the book and then some work from the book and some recent research that we have been doing in the lab. So this is a beautiful illustration from the book by Caroline Hamels, and it highlights some of the insights about what are the core aspects of tangible and embodied interaction. So that will be kind of sensing and extending the body, accessing information through our perceptual motor skills, facilitating interaction and collaboration with other people and with our environment, and empowering people by providing kind of mediated forum for expression, speculation, and debates. So tangible and embodied interaction really try to move away from the traditional graphical user interfaces to support interaction in this broader context. And as we were writing the book, kind of the global landscape of technological development and societal challenges were very much kind of in the front of our awareness. So just to name a few, right, of course, in the social challenges of war against democracies, of course, what we're seeing in Ukraine, but how can we use tangible and embodied interaction to support efforts toward peace and empowering people, empowering democracies? How can we use tangible and embodied interaction within the context of eliminating racism and increasing equity and equality? How can we use tangible and embodied interaction within the context of global problems such as climate change, future of work and learning, public health, not only pandemic, which of course is a major crisis, but also thinking about mental health, which is current crisis on college campuses, and thinking of course on personal medicine, which was the topic of my last BostonCHI visit a couple of years before the pandemic. And of course, taking into account the technical environment and the technical developments, which provide the context for this emerging field in human-computer interaction. So here is kind of the overview of the content. And in general, we try to consider tangible and embodied interaction from 5 different facets, thinking about concept, design, technology, cognition, and aspiration for the futures of this field. So we start with kind of historical overview and a review of some exemplar system. And then we look at tangible and embodied interaction that is deployed in the wild, either as research prototypes that have been deployed in museums or in classrooms, or products that implement some aspects of tangible and embedded interaction. We look at the conceptual foundations, theories of embodiment from cognition and philosophy, mediating technology, thinking about design aspect, aesthetics of tangible and embodied interaction, and then new ways for evaluating interfaces in this field and considering path forwards. And since we were kind of really wrapping up this book a year ago within the context of COVID-19, we really wanted to also talk about this tension between something that's tangible and our kind of hesitance to touch things and share environment. We're still meeting online. That's kind of the opposite of embodied and tangible. And how do we overcome this tension within the field of tangible and embodied interaction? So this is really a community effort. The book is highly visual. It has more than 350 images, which is one of the reasons that it takes us a long time to clear all these kind of intellectual property rights and make sure that we bring this book with this visual approach. We have a very insightful and generous foreword by Hiroshi Ishii. We have remarks by the president of the ACM, and we have 16 vignette contributors that added additional perspective to the book. So I want to talk about my own research within the context of how tangible and embedded interaction can enhance collaboration and learning and in work. And the overarching question really make me interact with 3 different activities, with developing frameworks and technology that enable the development of emerging tangible and embodied interaction, as well as with developing new ways to evaluate this impact of interactive systems on users. And in general, in my work, I'm kind of focusing on driving problems that come from outside of human-computer interaction, and in particular working on designing for data-intense fields and areas. By the way, I can't see the chat, so if anyone has questions, feel free to kind of raise your hand and then it will pop to the front of my screen and I can address it. Or feel free to kind of just interrupt and ask questions. So today I'd like to provide an overview of some work, more recent, and some work that we did in a few years, about 2 domains. First is making the invisible tangible, helping users to interact and make sense of biological data sets. And the second is enhancing data-driven collaborations. And here we're thinking about co-located collaborations as well as remote collaboration. So today is just a high-level view of some of the projects that I've been working on recently. But if you have questions, I'm happy to dive into the details of any of these projects. So within the context of a global pandemic, it's obviously important to make the invisible tangible. And it used to be the case that we were working on helping scientists and helping citizen scientists to make sense of biological data. But within the current context, I think it's really important to also think about future scientists, think about children, and thinking about communicating complex biological information to the general public. And if there is one thing that we learned during COVID-19 is how important it is to reach out to the public with accurate information in a way that will allow multiple people to kind of make decisions within this complex context. So how do we design interfaces that make invisible tangible, and how do we help users to learn and discover with biological data? And there are several considerations here, right? Thinking about visual and tangible representations of biological data, thinking about spatial interaction. How do we integrate and support embodied learning through gesture manipulation? And how to support collaboration as part of the exploration process. So some work that we did focusing on future scientists. So this is Synfloyd, a museum exhibit that was a collaboration with curators from the Tech Museum of Innovation in San Jose in California. And let's see if I can play it. I'm not going to play the video right now, but the exhibit was consist on small interactive screens that you could manipulate through gestures. And the idea was to allow museum visitors to go through different stages of a very famous synthetic biology experiment that take biological cells, specifically bacterial cells, and introduce genes that can recognize particular chemicals into the bacteria. And the bacteria would report on the presence of these particular chemicals through the creation of fluorescent proteins. So here we have the different genes that we introduce into the bacterial cell, and we try to imitate the gestures that scientists would take so that the children will get to work with the original kind of hardware from the lab, as well as to repeat the gestures of pouring and shaking and kind of mixing things together. Let me play a very short part of this video. So here you see a gene. And the user is inserting the gene into the bacterial cell. So first working with a plasmid, and then taking that plasmid and adding it to the cell that's kind of in a little petri dish. Getting to replicate some of the gestures that scientists would take in the lab. And here you see the plasmid inside the bacterial cell. Another museum exhibit that we created, and this is a museum exhibit that was developed in collaboration with Tufts University, researchers from Marina Berry's group, as well as with the Tech Museum of Innovation in California, and was also deployed in the Boston Science Museum. And this is a museum exhibit that kind of bring the motivation for designing building with biology for children based on research from NASA and MIT that looked at how bacteria could be useful to take resources that are available on Mars and use them to create materials that are necessary in order to sustain kind of long-term research missions on Mars. The same research inspired The Martian, so you can kind of have a feeling of what we were thinking. And the idea here was to take tangible blocks, one that represent a resource and one that represent a product, and connect them together into a biological circuit that could be inserted into a plasmid. You can see the plasmid cell kind of here on the interactive tabletop. And then the museum visitors will be able to take that plasmid, add it to a bacterial cell, wait for the colony to grow and release that colony into Mars to support researchers that would instruct them with kind of what are some of the resources that could be converted into desired materials. So here we can see a short video that shows this interaction. We can see the two tangible blocks. Again, there is mixing and gestures, adding bacterial, a cell, waiting for a colony, and then releasing that colony into Mars, where it consumes a particular resource and make a product that could be used by the astronauts. And this museum exhibit was actually very successful. So it developed into a collaborative video game that multiple users could play together in order to complete a research mission to Mars. And we haven't been able to support that video game in recent years, but I heard recently from a museum that is still using that video game for users that are coming to visit. It's also used apparently in several biology middle school clubs that I wasn't aware. So it still has its own life, and you can find it online. It's called Back to Mars. So we talked about the importance of evaluating impact. So several dimensions that we have been evaluating when we were developing new exhibits have to do with engagement. What are the holding times on this exhibit, how attractive it is, kind of enjoyment. We also look at collaboration patterns between children and adult and children, how adults intervene in the activity. We looked at what people learn based on the terminology that they use and the explanation that they could provide for the phenomena that they explored in the museum. So recently with COVID-19 crisis, we looked at how can we visual biological information and make it more accessible for the general public. And this is work that is being led, it's still happening, by Ayana Sil, who is a PhD candidate at New York University. It's a collaboration with Oded Nov and his team, and it's part of an NSF research that is funded to look at how do we make the invisible tangible. So here we couldn't work with tangible information remotely as we moved to work online. So we were thinking, how can we leverage embodiment? How can we leverage self-focused filters, a little bit like Snapchat filters, and use it to communicate complicated information? So early in the pandemic, in 2020, we looked at how can we communicate information of hand washing. So here we have a video of hand washing, and this is kind of one condition that users were able to see. This is a second condition in which we also communicated scaffolding of the impact, and the self-focus condition with augmented reality filter, and here is the reinforcement and the self-focus condition when the user kind of put their own hands and they see the germs disappear from their own hands. And we looked at how these different presentation mode affect intention to adapt particular behavior. And we saw that the AR kind of self-focused videos impact how the users kind of express their intention to apply this procedure. And it was also mediated by their perception of the severity of the threat. And then we looked at how we can communicate vaccine information. So we worked with animation from the Scripps Institute in order to look at self-focus versus avatar conditions to communicate vaccines, specifically how vaccines work. And here we measured not very much intention, but rather kind of risk attributions, whether kind of risk is attributed internally to the behavior of the user and the user can mitigate their own risk, or whether risk is something external that is enforced on the user. And we saw that the self-focus really kind of impact the internal risk attribution, but not the vaccine intention themselves. And recently, we also been looking at how can we use the same idea of self-focused interaction, not only on the user itself, but also on their own environment in order to communicate information that has to do with internal indoors air pollution. So here you can see different conditions in which we present air quality demo to users. So here is kind of the control condition. It's just kind of general presentation. Here is a presentation of self-focus. However, the data itself is projected either on the environment, and the last condition will be the data is presented on the user body. And this is a study that is currently ongoing, and we try to look at the effect of self-focused augmented reality and the object presentation on issue involvement, on the risk perceptions of users, and whether it impacts kind of misinformation correction. So this is all ongoing study, and it requires us to develop our own tool to run these non-mediated online studies that require users to use these filters. So some of the tools that we had to develop are tools that will allow us to monitor whether the online users are using the augmented reality filter correctly. So we have this new platform that take screenshots along kind of different points in the study, so we can monitor whether the user is indeed kind of using the camera and kind of present their hands to the camera the way that we would like it to work. So maybe we can stop here for a couple of questions before I switch to a different content domain of supporting data-driven collaborations. So I can stop sharing for a minute so I can see you and see if there are any questions. Anyone? Can people unmute themselves?
Absolutely.
Okay. Okay.
How did you measure, you say the hand washing thing, had an impact on the participants. How did you measure how much of an impact or whether it was really having one?
Yeah, so we were kind of measuring intention. So we couldn't measure that users actually adapt the routine. So we were measuring their intention to adapt the routine. And we asked various questions that look at intention. We used standard questionnaires for medical informatics. So we looked at different statements such as I'm intending to use this hand washing routine in different situation and in different contexts. So there was some repetition about the measure of intention. And this is the instrument that we use. It's actually interesting because just before the pandemic, my student Ayana came up with the idea, how can we use augmented mirrors to enforce this behavior? So our original plan was actually to use stickers as low fidelity prototype on kind of the mirrors in the bathroom in order to demonstrate different hand washing routine, and then to kind of have a timer that measure kind of gestures. And just as this became less relevant, since we couldn't have kind of the tangible and in-person prototypes, hand washing became even more important than we thought before. So we thought, okay, so how can we take this important information and make it available online in a way that is playful, but also kind of perhaps kind of driving change in the perception of users? Demetrius?
Question. Have you or anyone else tried to provide information while people are actually washing their hands, either with some kind of, VR goggles or, AR goggles or I mean, I guess it wouldn't be hard with all the laptops and phones people have. They could put it, by the sink, because I assume one of the big problems is no one washes their hands for as long as they should.
Yeah, so we did not. However, Apple Watch has an application that measures how long you wash your hands, and it will kind of nudge you and tell you that you didn't wash your hands for long enough. So I see my son is kind of washing hands and continue to wash hands. And it can even match with a little song. So his app is coming with the default of happy birthday. So like happy birthday to you, happy birthday to you, and measure the time, and it knows to recognize the gestures. So this Apple Watch intervention came much later. So I think it's kind of relatively new, but it's definitely a direction of using wearable technology to be able to identify the context in which you wash hands based on gesture recognition and provide appropriate information.
One more question. So for people like me who don't really know the field at all, what aspect of which of these manipulations or aspects of what you're doing are really part of what would be called embedded or interaction? Or so it's more kind of like a definitional question, I guess.
Right. So with tangible and embodied interaction, we really try to focus on sensing and extending the body. So here, this is kind of a minimal version of embodiment. We were focusing on, can we measure, the body in the sense of, can we identify hands, and we can present information, on the user hands using, the body as a way to contextualize the information. This is a kind of lightweight embodied interaction, but it worked with a quick intervention that we could deliver online early in the pandemic.
Great, thank you.
Okay. So I think that we're going to move to another content, and then we can go back to ask questions. So let me find how to share my screen. The video panel. Okay. So the second context, kind of thinking about the future of work, has to do with how do we support or design for data-driven collaboration. So here we're thinking about two different contexts, the context of remote collaboration and the context of collocated collaboration. I'm going to start with collocated collaboration. And here we were thinking, how do we support users when they collaborate on decision-making, and specifically decision-making that has to do with browsing and manipulating and making sense of large quantity of information. So how can we measure and kind of facilitate visual attention? What structure of collaboration can we facilitate in different configurations? And how can we support spatial use of the surface? And specifically, we were interested in looking at this very large tabletop user interfaces. So this is an interactive tabletop. It's large, it's the size of a conference table, and there are 8 people that are comfortably sitting around it. You can imagine interaction with this device similarly to sitting around a very large iPad, right? So this is a very large iPad that consists of 4 different cells. Here is the configuration. And what we did in our study is we brought together a team of 8 users. And these 8 users were asked to work together to make portfolio-based decisions, exploring information. So specifically, the task in this study was to look through information of different projects at Wellesley College. And through these different projects, there were hundreds of projects. They had to choose which projects they would recommend for funding. And they had to make the decision based on different categories. So they had to support several projects that kind of refer to play, several projects that have to do with supporting diversity, several projects that have to do with student lives. So there was much discussion, but the task itself was quite generic, and it was similar to a task of selecting from different categories in a portfolio. So similar to how you would recommend kind of funding grants, funding companies, any portfolio task. And we looked at the decision-making process and how would people collaborate around such a large tabletop. So we had a top camera, and here you can see the screen for this view. And we analyzed both video data as well as computational data, looking at verbal interaction and tangible interactions around the tabletop. And what you're seeing here are the network diagrams that illustrate both in red the verbal contributions and in blue the tangible contributions of interacting with virtual content on the tabletop across the different groups. And by visualizing the data in that way, we could very quickly identify different working styles of teams. So we see that some groups broke themselves to kind of pairs. Some teams work in subgroups of 4. Some teams work as an entire group, but one of the users took the kind of leader role. And this new way of visualizing interaction in teams allow us to kind of get better understanding of how these teams collaborate together. Some of the computational data that help us to create this network diagram were heat maps that we were creating through frame-to-frame differences from the top-mounted cameras that we had above. So here you can see the heat map of interacting, only tangible kind of interaction with the content. And again, you can easily recognize the different interaction styles between users around this team. So you can see teams that broke into 4 pairs here in the lower right, and you can see the team in the kind of upper left that work as kind of one team when there was a leader, and the leader in that case was mostly kind of leading verbally rather than tangibly. We also developed new interaction techniques that use eye tracking in order to determine when users are collaborating based on their visual attention. So whenever users were looking at the same panel of the table, we were assuming that they are working together if that interaction lasted. So let's see how this works. Here we can see 4 users and they were wearing eye tracking devices. Data collected by one eye tracker. View after it was processed, so you can see that we were able to recognize and divide the surface into 8 different areas. And whenever we have, so here we have a line that represents each user, and you can see whenever users are sharing visual attention in a particular area. So we were able to produce, this is not in real time, this is kind of post-processing, we were able to produce an output that described the visual attentions of users throughout the interaction around the tabletop. So recently we were thinking, how do scientists collaborate remotely using virtual reality meeting? So just to kind of go back, we basically had the new method for using eye tracking data, gaze data, in order to determine when users were collaborating throughout the interaction. So what you saw was a video in which users were using eye tracking devices, and in post-processing, we were able to identify where the eye tracking gaze data of 2 users were looking at the same section of 8 sections that we divided the interaction area. And our assumption is that if they're looking for a little while within the same area, that means that they're working together on a shared context and collaborating. So we were able to produce a diagram that would analyze from the computational data, that would analyze how people collaborated, what was the collaboration style that they took, and how did they shared attention throughout this entire interaction session. And our interaction sessions were kind of about 45 minutes. So you could have this analysis that will show you how the interaction of collaboration progressed throughout that time. So recently, I was collaborating with researchers from Tufts University, with Lenore Cohen, and this is work that is led by PhD candidate Montserrat. And here we're looking at how scientists collaborate remotely using virtual reality meeting spaces. So specifically, we're looking at how they use shared artifacts, spatial interaction, and what kind of cognitive support for ideation and sense-making a virtual environment can provide. So Montserrat was leading a qualitative exploratory study in which we had 2 groups of coral reef scientists that are collaborating on a current National Science Foundation grant for coral reef research. And we invited them to use existing VR applications for their regular research meetings. So during the summer, for 4 weeks, they used, it's July, August 2021. 4 weeks, they have been using Spatial and Nano, which are 2 different collaborative VR applications in order to conduct the research meetings. And we didn't tell them how to use the system, so they designed their own environments. And what we saw is that they really take advantage of the large spatial interaction that is afforded by the virtual reality environment. They use these large surfaces that were available on the virtual reality environment in order to arrange their information in such a way that they could kind of compare diagrams next to each other, that they can take a walk and explore the information in their own pace rather than one scientist sharing the screen and determining the share. And here we were kind of able to identify what are the features that provide cognitive support for the scientists. So increased focus and engagement. They didn't kind of share and multitask. There was a sense of increased presence, being together in the same space. They really liked that they could explore the data in their own pace and use the large space for spatial arrangement of the information in a way that makes sense, and the physical manipulation that they could pick up a coral reef model and interact with it and explore it. But there were lots of limitations in this environment. Beyond the steep learning curve, one limitation was the fact that they could not find an effective way to take notes. And the note-taking that they were looking at was, on one hand, to communicate with each other, but even more important for them was to take notes in a way that would allow them to kind of document their own thoughts to keep track of ideas that are flowing throughout the sessions for follow-up. So this is what Montserrat decided to focus her work on. And recently she worked with the scientists to develop a platform for testing new interactions for embodied note-taking. So she developed a new tool that could be embedded in a virtual environment and will allow scientists to take multimodal notes that consist of voice messages as well as images and videos of different interactions within the virtual environment, and then store these notes that are kind of stored inside these little spheres that are held by the users, store them either in a kind of two-dimensional notebook or in a pile of notes that they could arrange according to topics. So here's a short video that demonstrates how this interaction techniques is working.
We introduce Embodied Notes, a note-taking system that enables users to take multimodal notes in VR. The following concept video demonstrates the features of Embodied Notes implemented using the Unity game engine.
So you can see kind of recording a note and then playing it back, being able to store the notes. Sharing it with other individuals, and sharing it with everyone else in the room. Yeah, so this is really recent. This is very recent work. Montserrat will present this work at the CHI conference that will happen in a couple of months. And just to go back to the broader context, so I just wanted to show you some of the recent work that we're doing on how novel human-computer interaction can enhance collaborative learning and work, and the different activities that we were taking in terms of research to explore this. And I want to end with a kind of call from the last chapter of our book, looking at aspirations for tangible and embodied interaction within the context of the social challenges that are currently present, that call for deep engagement with societal challenges through synergies across kind of the science, technology, engineering, but also the arts and design, and kind of taking into consideration social, cultural, and embedding kind of the sensitivities of particular kind of social cultural context to create inclusive experiences. And is that in mind, I'm going to end with a call for a new conference that I've been organizing together with Andrew Koo from University of New Hampshire. And Andrew and I started this as a series of conversations about the future of work that had been happening online in the last 2 years. In recent months, we handed it to a new program committee that has outstanding collaborators that organize these weekly conversations online. And there will be an annual conference that will happen for the first time in a hybrid format in June. And if you're interested in submitting a paper, you have 2 days to do so because the deadline will be in March 10. But I hope that you'll catch up online with this series of conversations. All the conversations are recorded, so you don't have to catch them live. Yeah, so this is it, just acknowledging the many students that contributed to this work. And I'm going to stop sharing so I can answer questions.
All right, thank you so much, Orit. Yeah, so if anybody has questions, feel free to raise your hand, write it down in the chat, however, and then please, when called, read your question. Oh, we got a question from Jed. Go ahead, Jed.
Hey, hi, that was very interesting. Thank you so much for the presentation. I have an industrial design background and I'm moving into UX, and I'm sorely missing the tactility of everything and trying to figure out how to work that into new designs. And this is very timely to see what you've been working on. So that was great to hear. Thank you. I guess my question is kind of about your overall breadth of work. It looked like a lot of stuff was about understanding, and researching. And there was that one thing at the end. It looks like one of your students was working on a product that was a result of the research. And I was just kind of wondering the balance and the priorities of your lab, and how much is research, how much is building new things? What are your priorities? What are your interests in that kind of combination? And I'm going to just mute myself. Thank you.
Yeah, great question, Jaden. Thank you for joining us today, and good luck in this new endeavor in UX. You're in the right place and the right community. So just indeed, there is a mix of methods and perspectives that my lab applies. So we do science, right? We work with hypotheses and studies, but we also bring methods from design and from engineering. So we try to bring these perspectives from science, design, and engineering together in order to explore content. We're not developing products. However, we do develop prototypes that sometimes get deployed in the classroom, in museums, in industry.
Great, thank you so much. I'm going to check out the book, and I'm going to follow you, see some more information online. Thanks again.
Okay, thank you.
Looks like Jonah. Go ahead.
Jonah and the cat.
Yeah, that's Henry. So a lot of the work that you demonstrated seems to be more educational or research oriented. Have you been involved in any of the work around trying to add a more collaborative nature, say remote engineering teams?
So yeah, that's a great question. So my lab is a research lab within a research institution, and our focus had been research prototypes. Our collaboration is typically deploying, if we deploy products in the wild, it had been in museums and in classrooms. However, we do collaborate with industry, and some of our work is funded by industry. We didn't get to create startup companies quite yet. However, some of my students are excited and have been participating recently in startup competitions. So you might get to see some of the research prototypes happening as products in the real world. I typically allow my students to lead that effort with me kind of consulting behind the scene. But definitely there is excitement to share some of these prototypes in the future in a more commercial way.
I look forward to the next Slack killer.
Thank you.
Just a quick question about, at the end, you talked about a new conference, human-computer interaction of work. How will that be different from CSCW? Or why did you feel the need to start something new and not try to work it into one of the existing places like CSCW?
Yeah, so this is a great question. And this is, I'm kind of putting the link to the conference in the chat. This really started as a way to build community. So in April 2020, as we were all kind of locked at home, Andrew and myself started to think, how can we bring people together to keep thinking as a community on topics that we're focusing on the future of work? It also seemed that we're living the future of work at the moment. So how do we bring people together to think about these topics? And we started a series of conversations online every Thursday at 11. It's still happening. Almost every Thursday at 11, we invited a guest or a couple of guests to have a conversation rather than a presentation on a particular topic. And we tried a new format. We said, let's experiment with something new. Instead of having a conference in which you submit a paper, we'll invite someone, we'll organize it in a very agile way. We'll have a conversation. Half of it will be recorded so the community could use it as teaching materials or reference material, and half of it will be networking, just kind of having flowing conversation. And it worked really, really well. And it worked for a while. So for almost 2 years, we have been continuing these conversations. And now that we have a body of work in the sense of multiple conversations, it seemed to be the right time to bring people together into a summit conference format. So there is emerging community around specifically work, not necessarily social computing, that is seeking this less formal interaction. And that was really the foundations of CHI work. So our first formal conference will happen this June with a paper deadline. The goal is to be an inclusive community. So rather than going for a journal-like publication, to go with a more experimental format of papers in which we bring people together to talk about these new topics.
Great, thank you.
It seems that one of the best things about the future of work is that you get to see people's pets.
Well, if nobody else asks, I'll ask the obvious question. What's next?
Great question. So we keep thinking about the future of work. And currently we have a project with a group of scientists looking at the future of scientific collaboration and how can we have data-driven collaborations that are happening online. Talking about pets, I'm sorry, that's my dog. I'm also working with Andrew Kuhn, as well as with a team of researchers from University of Washington, University of Wisconsin, and Harvard Business School on a project that looked into mobile human-computer interaction in the sense of mobility and mobile environments. So how can we bring work into automated cars? And how can we bring new kind of working from outside of the office? So this is a topic that we have been thinking on. We have a Harvard Business Review paper that look at what people do when they don't commute. So what did they take the commute time to do? And we found out that most individual contributors use that time for more personal time. However, managers, especially managers in large companies, had been working longer hours, specifically more kind of coordination and meetings that are happening online, perhaps replacing what we used to see as people meeting next to the kind of water cooler and having kind of spontaneous conversation that now need to happen online. So we have been looking at what people are doing online, what people are doing currently in cars. We have another paper that just came out 2 weeks ago that look at people that are currently multitasking while driving. And unfortunately, we're talking about other people multitasking while driving in non-automated cars. So they was really not supposed to. And you'll be surprised to see that some people are even writing code while driving. Yeah, so this is all recent work. Yeah, it's important to mention that we're not good at multitasking, so please don't try it at home.
I'll go have a chat with my team and make sure that they're not the ones you caught doing that.
Yeah. Yeah, but in the context of the future of work, it seems that COVID really pushed us to kind of answer questions that we were kind of postponing for a while. So I think working in kind of mobile environment outside of the traditional office will be a problem that we will be addressing for the next few years. It's nice to see you all, but really Zoom kind of small squares is not the ideal environment. And I think that kind of together we can probably do better. Dimitris?
Just a quick comment on changes that COVID wrought. I mean, I do a lot of work for the trial court in Massachusetts. And the court, as you may or may not know, moves very, very, very slowly in making changes. And so, of course, they had been doing more stuff online, but when COVID hit and they had to do much more remotely, things were just accelerated tremendously. And so now there are, virtual registries and virtual court service centers where people can get help with Zoom, via Zoom, and there is more kind of electronic filing of things and, et cetera. More and more things going online and trying to figure out the best way to do this. So that was, of course, there are problems. No one wants to do, jury trials all online for a variety of reasons, and there are issues. But for many things, people just love being able to quickly do these administrative hearings that take 5 minutes instead of spending hours going to the courts.
Yeah, not to mention that it's probably increasing accessibility, right?
Yes, although the big issue is there is a big issue with a lot of low-income self-represented litigants who really don't have access to technology. And so I was talking with some people today, and the calls into the virtual court service center from Western Mass, they tend to be more on phones calling into Zoom, whereas in Eastern Mass, more people calling, from their computers with visual, and makes it easier in many ways. So there's still, and so the court is trying to set up, there are places where there are Zoom rooms in physical courthouses, et cetera, but there are issues.
Yeah, and I think it really, bring different questions of accessibility, while things becoming more accessible for people with disabilities, things becoming less accessible when you rely kind of solely on technology. And I think that's where it brings us to the broader context of thinking about societal structures. Can we kind of continue and provide public libraries that have Zoom centers? Right. And I saw in some public libraries, not only that you have the Zoom installed on the computer in a way that is available for others, you also have kind of a station to put your baby next to you when you work on the device, which is very nice to, again, think on less traditional audiences and how to create more inclusive technological ecosystems, because it's just the tools, it's the environment and the policies around them to increase accessibility.
And some of you may not know, but Zoom has nice simultaneous interpretation features where if you set it up, then someone coming onto Zoom can look at the bottom and choose the language they want to listen in.
Yeah. So thank you so much for joining tonight. It's really a pleasure to connect, and I hope to keep joining in the near future. Thank you.
Yeah, thank you so much for coming. This was a fantastic talk. Really exciting.
Thank you very much.
Thank you.